Hello, and welcome to this presentation on the fractional distillation of crude oil. Now in this presentation, we're just going to be focusing on what the fractional distillation of crude oil actually is, why we use it, how it works, and then we're just going to run through a couple of questions at the end based around this. So, what is the fractional distillation of crude oil, and why do we use it? Well, essentially we use it to separate out the vast number of hydrocarbon components in crude oil. And what we normally do is that we put the crude oil through the oil refinery. Now here typically the oil is put then into a fractionating column, and the components of the crude oil, so like jet fuel, gasoline and diesel fuel, can all be separated out. And then from here on out, these types of components can then be used to fuel the aviation industry and can also be used to drive us up and down the country. But how does fractional distillation work? Well, here we have a fractionating column, and the first step is to heat up the crude oil. The components of the crude oil will then start to boil off and enter the column. But note that the components that come off first are those with the lower boiling points and are thus the lightest. These lower boiling point components will then start to make their way towards the top of the column, where they will eventually cool back down to their boiling point. These components will then condense back into their liquid forms and will then separate off. The same process will occur for the higher boiling point components, but these will condense towards the bottom of the column rather than the top, due to how they don't require the longer cooling period to reach their boiling point temperature again. And what we can see in this image here is essentially what fractions are considered to be the lightest, leading through to the heaviest. Lightest evaporating off first, and heaviest evaporating off much later on in the process. Although it can also be pointed out that with the lighter columns they tend to have smaller carbon chains. With the heavier we see the opposite case. So therefore what we can say is that as the carbon chains increase in size, then the boiling points will also increase. This being due to the increasing number of bonds needed to break in each hydrocarbon species. Now for a couple of questions. So here I've listed what questions we're going to run through and from what exam papers I've taken them from. And so, question 1, gives us a table of crude oil fractions with their boiling points and carbon chain sizes. The first question is to name the fraction that contains hexane. So, from structural knowledge we know hexane is the straight chain of 6 successive carbon atoms. And therefore, by looking at the table, we can see that this number of carbon atoms corresponds to the petrol fraction. And that's our answer, petrol. So part B asks us to identify the number of carbon atoms that are shared by the two fractions kerosene and diesel. So, by looking at the two defined columns, so kerosene and diesel, we can see that the number of carbon atoms that is shared is 14, because both of those are present in each of those fractions. And therefore that is our answer, 14. The final part of A asks us to identify the number of carbon atoms in the alkane which has the lowest boiling point. So using our knowledge from the last slide, it's known that as the carbon chain length increases, so does the boiling point. Therefore, the simplest alkane we know of is methane, consisting of one carbon atom in its chain. So therefore our answer here would be 1 or just methane. Methane is also present in the petroleum gases fraction, represented by the singular carbon atom component. We can also see that this particular fraction shows us that the hydrocarbons in this fraction are those with the lowest boiling points. So on to part B. This shows us a graph plotting the supply and demand of crude oil fractions, and the first question asks us to name the fractions for which demand is greater than the supply. So by looking at the key and identifying the correct peaks, we can see that this is only applicable for the diesel and the petrol fractions. Thus, our two answers here would be petrol and diesel. So next, we are asked to suggest why these two fractions in particular would be in such high demand. So casting back to the first slide, we remember that we need petrol to help us move around the country in our vehicles. And this is the key reason to why these particular fractions will be in such high demand. We need the fuel to get up into the sky with our planes, we need the fuel to drive up and down the country in our cars, lorries, so on. So, moving on to question 2. What we have to do is, by looking at the following table and by using our own knowledge, we have to come up with 2 advantages and disadvantages of method A in comparison to method B with the creation of ethanol, and we also have to explain them. So, one advantage we can see is that when we're using method A, we are using a much lower pressure of operation. What this means is that we are going to be using a lot less energy, and that means that the process overall will be cheaper. Our second advantage here would be that we are using a renewable resource. So this case it will be sugarcane instead of crude oil. Now what this means is that as the crude oil is only in finite supply, then method A would be much more sustainable than B. But just to add, another advantage we could have mentioned is how method A would be considered to be a carbon neutral method. Reason being is that plants take in carbon dioxide when they photosynthesize, and so in this case, when the sugarcane is processed, this carbon dioxide is released back into our environment. Now on to the disadvantages. One idea is the fact that as carbon dioxide is produced during the creation of the ethanol in method A, we would make a direct link with carbon dioxide being a greenhouse gas, and thus mean that the production of CO2 would lead to more global warming. Although a second disadvantage is the fact that as method A has a stop-start process, this would lead to a much slower production rate of the desired ethanol product. This makes the overall process inefficient and thus mean that global demands would not be met. Now there were 2 other possible disadvantages we could have mentioned here. One of which being that with method A, we only actually produce a dilute solution of ethanol. So from that point, the ethanol would have needed further processing, making the overall process more expensive. The final choice of disadvantage here would then have been the idea of the fact that crops would have been needed to grow the sugarcane required for method A. This would have therefore led to there being less land overall for food production, or there would be less land left over if we were to perform this method more often. And that pretty much sums up the overall theme of the fractional distillation topic. So thank you for watching.